heard since morning that we really heard about the sustainability, the technology and innovation, health and well-being, and the human performance. It's quite nicely done in order of the flow. And now much sought after topic of the present and the future, the lithium-ion batteries. We're going to talk about, it's straightforward, the challenges, risks, and resolutions. It's a challenge, for sure, and the entire industry understands this. During the discussion, we were talking about that the designers are facing the difficulties. How do we address the issues of these lithium-ion batteries? Not the car alone, not the scooters alone, the parking and the charging base. So moving on to, let's be prepared for this challenge. I don't need to go into the general information what these lithium-ion batteries are, but there is another very crucial element. Due to their higher specific energy and ready availability, they are available. These small batteries, they are all lithium-ion. Lithium-ion batteries have surged in popularity to become the most used in the world, powering everything from smartphones to EVs, nothing new, and more. However, factors such as flammability of their components and sensitivity to water. Dr. Susan Lamont picked up more water or more smoke control. So these dots will be connected. The risk they pose and methods for effective mitigation and management of these risks. So this is what our topic is, and we are going to start with a panel which is structured in a manner that we will have one question each in the order of priority, and then if we have enough time, we will have the second one. I think introduction of the panelists is already there in this. However, it's Riyad Shami and Mrinal, Peter, and it's changed. Mark Fenton, did not see since morning. So here we start. Keeping in view that lithium-ion batteries have not been addressed well enough in our local code, we will move step by step. And as I mentioned, the objective is to have some takeaway and work on for the future. One statement from Mohandisa Salma was that we are prepared. That's a very powerful statement. Let's be prepared for the code provisions. I will start with Peter. What is a lithium-ion fire and lessons for fire engineers?
Yes, thank you.
Yeah, firefighters, important, firefighters, and other parties who may get involved with lithium-ion battery and its hazards. So hear from Peter.
So referring to what Sinclair said before in the previous speech, consciously competent is very much applicable over here as well. When you start investigating about lithium-ion batteries, you quickly, and the fire of it, you quickly come to the risk of thermal runaway. And if I read the sentence thermal runaway, then the flags are going up. You have the classic fire triangle where you need a fire load, you need oxygen, and you need an ignition source. That applies partially over with lithium-ion thermal runaways. It is that the oxygen is in the material itself and sets free during the reaction. So, in other words, even without or with reduced oxygen levels in a room, a lithium-ion battery fire can still take place. It's actually an exothermic reaction. And what I would say is that fire engineers who come across battery rooms involving, for instance, lithium-ion batteries should think what fire suppression means are suitable for this. And it can be that the classic, or more or less classic, inert gas fire suppression may not be suitable in the way that it is classically designed by reducing the oxygen to a certain level. Yeah. So to come back to the question, lithium-ion batteries, what's the hazard of it? It's a thermal runaway reaction, and in that sense, the classic fire fighting or fire suppression means don't always apply. If you look at standards, the NFPA 855 elaborates on this, and you have also the insurance standards, and they strongly, or NFPA strongly recommends or gives even design criteria for sprinkler protection, which is a little bit odd in this part of the world because you think electricity and water don't go together. And NFPA leaves the door open for other firefighting means, but insurance standards like the factory mutual or CHUP guidelines, they are a bit more specific, or they recommend, they recommend, that's what they can do. They strongly recommend sprinkler systems. So that answers your question?
Yeah, perfectly, absolutely. Right. So the code, the basic idea is that we have to put the basic perspective of this lithium-ion, which I say it's the present and the future. It leads me to really talk about going on towards the guidelines. We'll go to Mrinal. What are the current guidelines followed globally for production and risk management or risk mitigation of these batteries?
Okay, when we talk about the regulations on lithium-ion batteries, currently as you rightly said, that in UAE, at this moment we do not have anything, but we are moving forward in the right direction. If we look at European Union legislation on lithium-ion batteries, which was published this year in March. They have a clear roadmap of going till 2030, wherein specifically on from the manufacturing side, they have put a clear guideline on how the battery manufacturers, what factors they have to take in, whether it is in terms of sourcing the raw materials, whether it's in terms of production, then storage and transportation. So all those regulations are there from the European regulations in place, and like I said, they have a roadmap year to year till 2030. If we look at that roadmap till 2030, there is a huge push on sustainability, as we heard from the previous sessions. So when we talk about sustainability, one of the major factors is that internal combustion engines. If we take an example, they have to be, all the internal combustion engines, rather 90% of those have to be replaced by EVs by 2030. In fact, 13 of the 15 major OEMs across the world have pledged to that. So that's a big number. And if we also look at the growth chart of a battery industry, right from 2022 till 2030, it's expected to grow at 30% per year, with the value of this growth slated at about $400 billion by end of 2030. So with this growth comes a set of its own challenges and risks. So the major challenges remain in majorly three sectors: environmental, social, and governance. So.
Okay. Good point. I think it's a good perspective. I would like to connect it with the current industry perspective. The industry has the impression that codes and standards do not exist when it comes to addressing EVs, electrical vehicles. On this, Iyad, I will come on to the question, which I have a big question for you from the designer's perspective, being on the field. What is your take on the currently available codes and standards for the lithium-ion batteries and the EVs? A quick one.
So I would say yes. You can hear me. Okay, cool. Standards are lagging behind for sure. Standards are lagging behind for sure, but there are some specific items when you're talking about lithium-ion batteries that are already highlighted. For example, the charging stations. They are guided by principles and standards that are robust. But when you're talking about the operation or fighting those fires in terms of lithium, that's where the standards or the design does not really address it. NFPA Peter, you were touching about the 855.
855, yeah.
Okay, exactly. So there are standards that are relevant, and they just need to come up to what is now and what is present and anticipated in the future in terms of lithium-ion batteries.
Right, thank you so much. Appreciate that. It was a connecting question. And now I will come to Mark. It's what can be done to mitigate the risk in terms of knowing when a potential battery fire may occur?
Okay, so like with any sort of building system or fire system, one of the key things is early detection. And for lithium batteries, what you'll find is that a lot of the manufacturers, whether it's the battery pack manufacturers or the vehicle chassis manufacturers, will tell you that their battery monitoring systems, they'll monitor the temperature, they'll monitor high voltage, low voltage, they'll monitor the pressure in the tubs or in the casings. The problem with that is when you get a big battery pack, there are hundreds of batteries in that pack, and normally it's just one cell that's going. So one of the best ways to pick that up is what happens when that starts to heat, it gives off a gas. And one of the best ways to pick that up is using gas detection. And typically what happens is you get a hydrogen gas or hydrogen fluoride gas that comes off of that. And if you can pick that gas up, and normally you can sense that under vents, and most of these battery packs have a vent, so you can pick that gas up at the vent, that will pick any potential risk up way ahead of any battery management system because, as I said, you've got potentially hundreds or thousands of little battery cells in a pack, and the battery management system is looking at the weighted average of all whether the temperature, the voltage, and etc. Whereas one battery cell could be giving off hydrogen gas. So the gas sensors are very sensitive. They detect to parts per million. They're connected to a control panel, and that control panel can be connected to a fire alarm panel or a building management panel system or within a building. Or in the case of a vehicle, they can be connected to a small control panel in the cab of the vehicle, which in turn can then be connected to the central command station for the vehicle, whether it's a bus depot or whether it's a mine or something like that. What this does is, if those of you are familiar with things like air sampling systems that have been around for 20, 30 years, where we're looking for small amounts of smoke in an IT room or a computer room or something like that, really what we're doing is we're buying time. Okay, and buying time allows us to make smarter decisions, allows us to make more conscious decisions. So if it's a case of a building battery room, we can get to the battery room, we can isolate the power supply, we can call maybe the fire brigade, or maybe we can even deal with it with a handheld extinguisher. If you've got an apartment building, e-scooters are a big problem at the moment, where you've got a lot of these things catching fire because they've got cheap batteries, and they're stored under the stairwells. That actually presents a risk in itself, because now you're potentially creating a fire on an escape route in a residential building. So again, get to that, throw the scooter out the door, get the people out of the building, whatever it is you need to do. Or in the case of a vehicle, take a bus, the bus driver can move the bus, get it somewhere safe, get the people off the bus, make sure it's away from residential area or other vehicles that could catch fire. But again, the point is, early detection buys time. And if you can buy time, you can make smarter decisions. The risk of damage or damage limitation is greater. You can get the fire brigade there quicker. And ultimately, you can make smarter decisions and quicker decisions because you just have that extra amount of time.
Very good, valid point. You know, it leads me to a very connecting question. I think I'll go back to Peter. How are the industry sectors responding to the fire risk associated with these lithium-ion batteries?
Yes, when I consider industry sectors, I consider the two, what I think are main ones. One is the stationary battery areas, and that is, as the word says, stationary. And that, to me, is a bit more straightforward, let's say, because you just designed a new code for a new phenomenon. And there is not too much retrofitting required, because, for instance, stationary battery rooms are very much in data centers. That is not very much data centers, of course. Now the other and the bigger problem is, of course, with garages, parking garages, public parking garages, where they are designed to deal with normal oil or gas-powered vehicles. And now, of course, if you deal with these electric vehicles, where once a fire is going, it's very hard to extinguish it. That's something else. And there you see, of course, the magnitude of the problem. Because if you start implementing regulations and new regulations, there is of course a lot of retrofit work to be done. Because there's of course many garages in the world.
Wonderful. You know, I'm seeing a smile on Iyad's face. Probably we have only 4 minutes and 31 seconds left, so I'll go to my last question before we open the discussion. Iyad, considering the present and future giga projects currently underway in the region, especially electrical vehicles. Yeah, we know they are used everywhere, but electrical vehicle is a very in public domain, it's a challenge. They are becoming so relevant within the design process of tunnels and car parking structure, when we talked about the basement car parks. Could you share with us some of the fire life safety considerations and how to best address this matter in the design phases, leading to the authority acceptance for this? One of the discussions came with very senior, very specialized person that we are really worried about the parking structure, especially the charging stations. So last comments, and then we open this discussion for public.
All right, so it's a big question. There's a lot of consideration that needs to really be looked into, and we all understand the risks that are associated with lithium-ion batteries, which a lot of the previous panels have touched on the different mitigation measures that I will be touching on. So first off, we'll talk about thermal runaway. Peter did a great point where he explained what is thermal runaway and it's a chemical combustion at the end of the day. So thermal runaway is one of the risks that we need to consider while we're designing car parks or tunnels. The second component is, are we going to suppress it via a water-based system? You know, we understand their occupants are going to be there. We're not going to do any gaseous suppression system, of course. And to control a chemical fire, you do want to cool down the fire. You do want to provide a drench system of water-based. And that would control the cooling down the chemical combustion rather than extinguishing it. The third aspect is the fire service operation. So, you know, the presentation right before us did talk about how the standard operating procedure need to be updated, need to be brought up to speed to what is the now and the future of EVs and electrical cars or scooters, for example. And that, you know, civil defense or the fire service operation and emergency responders need to really come up to how to respond to lithium-ion batteries. And then, so just taking all that in consideration and the human nature of how to operate it, the awareness level of people that are operating these EVs really need to be brought up by using AI that DCD was talking in the beginning about and transmitting it in 180 languages. So there's a lot of mitigation measures that we just need to tackle as an industry and keep talking about it, and for the standards and guidelines to come up to speed with it.
Wish we had a lot of time. There are many questions, but we are running out of time. So taking a message that we need to have the code provisions in our UAE Fire and Life Safety Code. With that, I would like to open the forum. If there are 2 questions, we have 1 minute and 15 seconds left. Any pressing questions? Can someone take the mic, please?
Thank you. Being into passive fire protection, you know, I always think about prevention is better than cure. You know, so lithium ion, you know, what I think about is that we also need to see why the fires are happening. You know, so not only regulations on the lithium ion, we also think about the accessories. So if we see about the cheap accessories that we get, you know, in the market, so how do we regulate that? Because they are also something which is triggering the fires that are happening. So whenever we think about the regulation, I think this is one. The other thing is people who are picking up these accessories. I think there is an awareness level missing on the lithium-ion batteries. People just go and buy any charger in the market and put into a lithium-ion. So I think when we discuss and design regulation, I think we need to also push on 2 aspects of awareness as well as accessories that we are coming with to that. Any comments from?
If I may?
Go ahead.
Yes, thank you. So there are standards with regard to the proper manufacturing of batteries. I believe the UL has a certain standard on it, and it also focuses, when talking about passive, it focuses on those little cells, what was mentioned, being separated by proper constructions, for instance. And indeed, the charging, if you use, for instance, for your iPhone, if you use an Apple charger, that will stop when the battery is almost charged, and it will stop giving power. But chargers that you can find very cheap in the market will not do that, with all the risks, of course. So there should be more strict regulations around that.
And just to, if I take 1 minute of the time,
30
just to add to this point, what Peter said, and to answer your question on the public awareness, I think there is a need of raising the public awareness on overall use of the battery-operated small vehicles, which are widely being used in our communities and by the students per se. So to safe use of these vehicles which use lithium-ion batteries, along with their storage and their charging, there needs to be a community-run awareness by the authorities, of which I'm sure DCD is working on.
All right, I think Terry, do we have time for one more question?
Yes, one more.
If it's pressing, okay.
Yeah. This one for the Peter. The future is going to be flooded with a lot of ion batteries. So what is the disposal system available? Since if it is leached into the soil, it is a toxic. So what system is going to be the safe disposal of these batteries?
This is a wonderful question, but it requires a really long time. Truly speaking,
I will ask
you can comment, because recycling is the very critical aspect.
I will be short on that. So there is standards, and there is a lot of regulations in recycling factories, for instance, or recycling plants, where that disposal and even the risks of handling and crushing the waste, for instance, including batteries, it's a hot topic, yes, and it's a serious topic, and not everything is said about it, unfortunately. So,
all right. So with this we close this, and I will have a comment to say that when we talk about fire safety, fire protection, firefighting, I would say in one word, we all are responsible. And I will close this with one message from Quran. Bismillahir Rahmanir Rahim. Waman ahayaha faka'annama ahayaha nasa jami'a. It means if we save one life, as if we save the entire mankind. So take the mission, think about safety, think about others, appreciate others, and work towards the life safety. Thank you very much.